Picture we have like a container on our back. She's piled.
You guys got books? Go to page 400.
Hold it.
Page 400. All right, stay with me. This is just another way to solve for 400. Page 400. Another way to solve for delta H is using bond energies. It's just another way to do it. So in our notes, again, before we get into delta G, solving for delta H RxN using bond energy. So what we did the past couple days, actually it should be bond energies, sorry. What we did the past couple days was Hess's law, calorimetry, and different ways to solve for delta H using the heat of formation or using multiple reactions. So that's two ways. This is another way. So on page, I think it's 400. Page 400 here. Should be chapter 9, right? Yeah, okay. Yeah, page 400, but really it's 401. But if you look at page 400, 9.10 says bond enthalpy. I say bond energy. Enthalpy is the same thing, except that constant pressure, right? That's what enthalpy is. So if you look at the table 9.41, or 9.4, why do I throw ones at the end of things? 9.4, there's your bond enthalpy. And what does that mean? That's how much energy is released when that bond is formed. That's how much energy is put into it, absorbed when it's broken. So if you want to break a HH single bond, you got to put in 436.4 kilojoules per mole. If you want to form HH bond, then you're releasing that much energy when it's formed. All right. So I want to just bring this up because it's another way, and I do have a sample problem. I don't know if I copied it though, but you do have one in the book that you can do. I have a sample AP question. Well, we have time for that.
Why are some of these red?
It says at the bottom.
It says at the bottom there. Bond enthalpies for diatomic molecules in color have more significant figures than bond enthalpies for bonds in polyatomic molecules because the bond enthalpies of diatomic molecules are directly measurable quantities and not averaged over many compounds. So that makes sense actually, especially like the C double bond O, enthalpy in CO2, when it's averaged over other molecules because the length could maybe vary a little bit because of resonance perhaps and other reasons. That makes sense. All right, if you look on page 402, to find delta H, it's shaded there. It's the sum of the bond enthalpy of reactants minus the sum of the bond enthalpy of products. So the way I've always learned that and the way I've always remembered it, maybe you'll like it the way I phrase it, maybe not. I've always remembered broken minus formed. That's how we find delta H. So I'll write it both ways. So to find the heat of reaction, I always write this. The sum of the bonds broken minus the sum of the bonds formed. So when I say the sum, it means the sum of if it's more than one reactant, more than one product. And I'm not putting the bond energy in here, so I'm assuming that's what we mean. So the other way to write that is probably more accurate, would be the sum, there's my message on again. So there's the sum of the bond energy of reactants, or bond enthalpy, minus the sum, of the bond energy of the products. Because think about it, products are forming bonds, reactants you are breaking. You have to break reactants apart to form products. So this will give you the heat of reaction. So I actually don't have a problem written down, so we're just going to do the practice exercise on page 403. So let's do that right now.
Is this on the reference sheet?
It is not. This is the tricky part. If they throw this on the AP test and they say, just don't buy it completely. They say if it's not on the reaction sheet, they won't make you do calculations unless you can use something on the reaction sheet. I just don't buy it because this isn't a formula, right? It's just a method. So this could be something you would have to do, so I would remember this, okay? Broken minus formed or reactants minus products. So let's do practice exercise on the bottom of 403 where it says calculate the enthalpy of reaction for the following reaction. H2 plus F2 yields 2HF.
Or are you reading this mystical formula?
At the bottom.
Bottom of page 403.
Ah.
So it's the same rules apply though. As far as the summing, you got 2 HF, so keep that in mind. You got 2 of them. You only have one H2 and one F2, but you got 2 HF, so keep that in mind. And the example right above it shows you how to do it. So I just thought this was good to at least give you one practice. I'll give you another one for homework. So what are we doing with this lab? Lab due tomorrow, Friday. Lab's due Friday. Lab due Friday, March 27th. Well, problem set is all done. That's good. Amanda, did you copy down this bookwork?
Yeah.
Got some room in the box. It means I can fill it up.
Incorrect.
That's a false statement. You're
Not
very
all
confident.
next week.
That's-
Oh, sorry.
Fill it up next week. All right.
Any more ink touches it, it's gonna just magically erase itself.
Shane's in a cup.
Yeah.
That might
That's your number one threat,
Yeah,
right?
dude, I'm worried about them. That could be legit.
Shit, gotcha.
So you just have to use the chart on page 401. You should be nearing completion. If you want to check your answer, go to page 413. It'll have the answer to practice exercise 9.13.
Question. So, in the example above, for H2,
Yep.
it says 0. Is it 0? Because on the chart it says HH.
It's 436.4. What example says 0?
Above. Like, directly above.
That's using the Don't do the ones we've already done. Don't do the heat of formation from appendix 3. Don't do that method. This is different. I just want you using bond energy. So on page 401,
Okay.
that one. Don't do the heat of formation. Just use the bond energies.
Your hand has escaped from the hole.
Less than 7 days. I'm excited.
T-minus
Last
6.
time I asked it was 3 weeks, so cruising.
Did you guys check your answer?
What page do I find?
Page 413, 9.13a. The answer should be the same. They're off by a tenth. So equation A, or equation 9.3 would be the bond enthalpies. I mean, I'm going to show you how to do it anyway.
I don't think my answer is ionic. 9.13, my bad. Yard. Victory is mine. The Kraken has been slain.
If I could get these uploaded, they'll be very entertaining. All right. So H2 plus F2 yields HF. Now this should make sense to you. I know I say that all the time, and that's just kind of like ironic, I think. But if you understand what's happening, if you break these two, it's going to need to absorb a certain amount of energy. And then if you form these two bonds, that should release a certain amount. So if you can find the difference, that's the overall energy of the reaction. So HH has a bond enthalpy of what? 436.4. 436.4. FF is what? 1 what? 156.9. And then you have 2 of these, right? 2 of those. So what's each one of those? 568.2, 568.2. But these are negative. Why? You're right. When you form it, you release it. These are positive. So when we want to know the delta H of reaction, it's bonds broken minus bonds formed, or bond energy of reactants minus bond energy of products. So either way, we get 436.4 plus 156.9 minus
1,137.
1,000 what?
Or 1,136.4.
There you go. So that's your products. So this added together minus that gives us what? Negative 5 what?
43.1. But no, we can do it that way.
And it's what is it? Kilojoules per mole, right? Is that the unit? Yeah. And it is negative, correct?
Wait, it wouldn't be
Yeah,
minus
it
a
wouldn't.
negative.
It wouldn't. Yeah, it wouldn't be minus a negative because that would change the entire answer.
It would just
Did
be
you
minus
make it
it.
possible?
What'd I do
Plus
wrong?
a negative.
What did I do wrong?
You don't have to add the
You're
negatives.
subtracting a negative.
Yes.
The 2 would make it positive. Jeremy's right. Jermichael Finley has come with the proper answer.
You wouldn't have to add the negative in front of the 568.2.
Yeah, just leave it positive
Yeah,
like
just
up in
leave
the
it positive.
equation.
That's
and
what
then
they do in
just
the
subtract
example.
it,
So this
yeah.
here. Oh, I see what I did. I was treating it like the bond formation, right? So this minus this gives us that. That is a negative answer, though.
Yes.
Yes.
Will the second part, the product thing, will it always be negative? For
The
like,
what?
The product, the heat energy. When
Well, in real, yeah, it is, but remember, it's only negative because we want to show it's being exothermic. The actual energy isn't negative. That's why we don't put it in.
Right.
So that was my mistake. I was treating it like the formation.
so we never put negative.
Not for bond energy. So I want to make this clear, because the reason I did that is I was still in the formation mode. So if you're labeling delta H values, that is negative or positive based on XO endo. But bond energy is just an actual number, an actual energy. So we don't put the sign on it. So it's different. It's not delta H. These are not delta H values. They're bond energies. It's different. So I was still in the other mode. My bad on that one. So yeah, Jeremy, we don't put them here. We just plug them in and subtract, and the sign at the end will tell us what delta H is.
Alright.
So, good question. Yeah, we are basically out of time. I'll give you one practice problem for this. Chapter 9, number 72. Chapter 9, number 72. That's going to practice this bond and enthalpy stuff. And tomorrow, we'll hit delta G. I will be after school tomorrow.